Today, we are continuing the conversation about solving equations. Specifically, you can see 1.08, variables on both sides. And so, while we saw really simple one-step and then even two-step problems last week, we're going to start to move into just some more things happening. Before we do that, though, I really want to stamp two vocab words because they were admittedly a sort of like iffy last week. And so the first one is going to be coefficient. When we talk about the coefficient, what we are talking about is the number being multiplied to the variable. The number being multiplied to the variable. This can be found before the variable. Now, there are sometimes some sort of like exceptions to this when we think about fractions, but 95% of the time we will find our coefficient immediately before our variable. And so we already have one of these in our notes in a previous section, but I want to put this again to really drive this home. If I have something like 4x squared, if I think about coefficient, my brain needs us to immediately jump to the 4. My coefficient there is the 4. It's the number found in front of the variable, which is x. And then not really mentioned here, but something I want you to annotate is that 2, that's our power. And so we have our coefficient, variable, raised to a power. And so then we're going to talk about what it means to actually isolate. And so we've been doing this. This is not as big of a concern I have. However, it is not a word that we have stamped together. And so when we isolate, we are actually rearranging an equation so that the variable is on its own. We are rearranging an equation so that a variable is on its own. And so specifically, right, things that we would look for, x equals some number. Might not be x, it might be like y, it might be h, l, m, s, whatever it is. We're looking for that variable equal to a number and nothing else going on. Now, raise your hand on the x that I have written. What is the coefficient? Raise your hand on the x that I have written. What is the coefficient, Gabby? 1. When we isolate, we need 1 of something, right? If we think about all the work we've done, I didn't want 2/3 m. I didn't want 6y. I need 1 of that variable. Once you have these both, flip your notes so that I can see. Go there. Ariana, thank you. Gio is there. Natalia is there. Malik, thank you. There. Take about 10 more seconds to get the rest of this down. Good. All right. Example 1. We want to solve for x. Now, again, I want us to really annotate this. It means we're really isolating x. Okay, so I need x fully by itself on its own. Well, if I look, all of a sudden, oh, I have variable terms on both sides. And so when I think about a starting step, I actually have options. And so raise your hand. What is a possible starting step if I want to start solving this? Janaya. Say it one more time, nice and loud. Grouping? Grouping's not quite what I'm looking for. I'll give you a hint. You can jump right into inverse operations with this. Gabby, what's one possible starting step? Subtract 27 on both sides. I could do that. What's another possible starting step? Carol. Louder. I could subtract 3 from both sides. That also works. What's another starting step? I've got subtract 27. I've got subtract 3. What else could I do? Shamir. Minus 5 what? 5 what? There it is. Minus 5x on both sides. There's a third one. And there's actually a fourth. Raise your hand. What's the last one I could possibly do? Gio. I could subtract 3x. And so all of a sudden now we have 4 possible starting points. What I'm going to tell you is that any of these are valid. None of these are considered wrong. The steps we do after our first step are pretty much locked in, but our first step, we have options. Now, this is really going to come down to mathematical preference. I like my variables and my coefficients to stay positive. And so I'm actually going to opt for subtracting 3x from both sides here. Now, when I line this up, please notice, minus 3x in my line by line, directly under the 3x. Minus 3x directly under the other x term. I'm not putting it under this 3. I'm not leaving out my x. I'm being very particular and precise in my line by line. From here, yeah, 3x minus 3x is 0. That cancels. It's exactly what we want. So I'm going to get 27 is equal to 2x plus 3. Now, from here, this is why I was saying like we're sort of locked in at this point. As soon as you commit to a starting step, your next few steps truly are locked in based on what you did first. I have a constant on the left, and I have variable and constant on the right. And so if I'm thinking about isolating x, well, the thing that's an issue now is actually the 3 that's on the same side as it. And so I'm going to get rid of it. So we're going to subtract 3 from both sides. Okay, well, everybody, 27 minus 3 is 24. Okay, and so 24 is going to be equal to 2x. Now, I'm almost done, and this is where we get into, I actually don't want 2x. I want 1x, and so raise your hand. What am I going to do on both sides? Gio? Divide by 2. And so I'm going to get that x is equal to 24 divided by 2. Everybody is 12. Good. Are there questions on the steps we took to solve? All right, then, down below, in the key takeaway, we are going to write when using inverse operations, we must cancel a term to be considered a correct, I'm going to put this in quotes, move. When using inverse operations, we must cancel a term to be considered a correct move. All right. We're going to shift now to example 2. We're just going to close out notes. Example 2. At a baseline has more going on. It has more going on. And so I actually want a raised hand. What does this scream at us that we should probably do first? Aiden, distribute. As soon as I see that that 4 is next to those parentheses, my brain is going distribute, 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 distribute. On the left, I haven't done anything. Stays as is. Stays as is. Negative 3x plus 3 is equal to now 16 minus 12x minus 2. Now, I do not want to jump into inverse operations. I don't want to yet. Raise your hand. What should I do first before I perform inverse operations? Gabby. Simplify the 16 and the negative 2. I have like terms. I need to combine them first. And so I'm going to have negative 3x plus 3 is equal to, I'm going to put my variable first, negative 12x. And then, well, this is just 16 minus 2. Everybody, 16 minus 2 is? So plus 14. All right, well, from here now, I'm essentially back at something that looks like example 1. All right, well, I'm going to add 12x to both sides. Again, I generally try to opt for my variables to be positive. So I'm going to have 9x plus 3 is equal to 14. Subtract the 3. Learn that 9x is equal to 11. And from here, I don't want 9x. And so raise your hand. What am I going to do on both sides? Keyshawn, thank you for raising your hand. Louder. Divide, yes, more specific. Keep going. By what? Careful. 9. Why do I want to, raise your hand, why do I want to divide by 9? Gabby. Isolate the x. Specifically, raise your hand again. 9 is the what? All right, louder. Coefficient. Everybody, 9 is the coefficient. That is why we are dividing by 9. And so, we're learning that x is equal to 11 over 9. It does not get better than that. 11 is prime. Fair question. Yeah, one sec, I'll be around. I'll be around. Sure. All right, I'm hearing people already start then. Fold these in half. Get these glued in. If you did not get a glue stick, just quietly look around and see if you can have somebody's. But you've got 1 minute to do this. Go.